Hey everybody, it's Dylan with the Viper Staking team. Today, I'm going to give you an overview of our recently completed Catalyst Fund 8 project entitled Cardano Development Library in C++. The goal of this project was to develop the basic infrastructure of a C++ Cardano SDK. We chose C++ for its performance and popularity. C++ is one of the top 5 programming languages in the world and is used extensively for game development. We hope this library might eventually be used for game engine integration with Cardano. The library is called libcardano, and it's hosted here on GitLab. The goals of the Catalyst Fund 8 proposal were copied over into this GitLab issue so that we could keep track of our progress. As you can see, we had 4 main goals, the most important being the ability to create keys from mnemonic seed phrases, and to be able to build and sign basic transactions. All of these goals are now complete. Let's take a quick look at some of the code. This is one of our unit tests for the library, and it's a good example to walk through because it exercises a lot of the library's capabilities. First, we have here a seed phrase. From this seed phrase, we can generate a Cardano mnemonic object. We can then generate a BIP32 private key from the mnemonic. Once we have this root signing key, we can derive a payment signing key using the standard derivation path. We'll use this payment key to sign the transaction. This is the CBOR from a signed transaction output from the Cardano CLI. I pasted it in here so that I could verify that the transaction we generate with our code will then in turn generate matching CBOR after we sign it. Here's the 2 addresses, the from and to address. Probably should have just derived the address from the payment key. I didn't do that here. That is exercised in some of these other unit tests. I probably should update that in order to just have it be continuous, seed phrase all the way through address. This is some of the transaction inputs. It's not connected to a node pulling UTXOs out of a wallet, so we have to give it the input data of the UTXO. So this is the transaction ID of the UTXO that we're going to consume and its index. This is how much ADA is in, or how many Lovelaces are in the UTXO, and this is how much we're going to send. So we start to build the transaction by creating a Cardano Babbage era transaction structure. We then start filling in parts of this structure. So for instance, we create a transaction input object here and insert it into the list of inputs. We then create the to and from address addresses as Cardano base address objects from the Betch32 encoding. These strings here are the addresses in Betch32. We then add the outputs. So we manually build the outputs here by giving it an address and the value. So this is the UTXO that will return to the wallet. So it's going to be what is left of this after we send this much and pay the transaction fees. This is the output that is actually sending the transaction amount to the to address. We then set the fee and the time to live. Then we use the transaction signer object to sign the transaction with our payment key that we derived from the mnemonic. Our unit test then verifies that the transaction serializer is able to generate CBOR that matches the CBOR output from the Cardano CLI. I recently just built the library and ran all the unit tests. As you can see, we have 10 unit tests that exercise various capabilities of the library. And this one right here passed, which is the unit test that we're looking at here, sign and send. So the CBOR that was generated by our library matches that was output from the CLI. All right, well, that wraps up my summary. I just want to thank everyone who supported us in our proposal in Fund 8. And please look for new proposals coming soon in Fund 10. And please interact with us. Follow us on Twitter, join us in our Telegram or Discord, and let us know what you think of our proposals and what you think we should work on next. Thanks, everybody.